All right, take a look at this question. Okay, in a naturally occurring sulfur, the relative abundance of sulfur 36 is only about 0.01%. Calculate the number of atoms in this isotope that will be present in 1.0 gram of natural sulfur. Okay, this question cut across percentage and moles and number of particles. Okay, now do you know what this means? When they say that the percentage or the relative abundance of sulfur 36 is 0.01%, it means for a sample for a sample of 100 grams of sulfur, okay, we have about 0.01 gram of sulfur 36 in that sample. Okay, the question is the number of atoms in the isotopes in this isotope in 1.0 gram of natural sulfur. Before we find the number of atoms, we first of all need to find the number of the mass of sulfur 36 in 1 gram. In 100 grams of sulfur, about 0.01 gram of sulfur 36 is present. So in 1 gram, that's 1.0, in 1.0 gram of sulfur, 1.00 gram of sulfur, the natural sulfur, how many grams of sulfur 36? I'm going to represent it as x. X grams of sulfur 36 is present. Okay, so our x is equals to 1.00 times 0.01 divided by 100. This is just a simple mass. Okay, cross multiply then divide. Okay, good. This will give us about 0.0001 gram of sulfur 36. So in 1 gram of natural sulfur, we have 0.0001 gram of sulfur 36. Okay, then we can now find the number of atoms. Okay, how do we find number of atoms? We already know the mass, so let's find the mole of atoms, because we know that for 1 mole of sulfur we have about 6.02 times 10 raised to the power 23 atoms of sulfur. So this is straightforward. So let's find the mole, that is N, of sulfur 36 in this mass. Are you with me? Okay, remember mole is mass over molar mass, and the molar mass, check your periodic table, the molar mass or molecular mass of sulfur is 32.1. Okay, so we are going to have mass over molar mass. Remember, mass over molar mass, which means 0.0001 over 32.1. So the number of moles of sulfur 36 present in that mass we were asked for is what will it be? This divided by this will give you 3.125 times 10 raised to power minus 6 moles. Okay? Since we have found the moles, the rest is history. Convert the moles to number of atoms or particles. Okay? Okay? So we move here. Remember, 1 mole of sulfur 36 contains 6.02 times 10 raised to power 23 atoms of sulfur 36. Remember that formula or that rule? Okay. So, if that is true, the number of atoms, the number of atoms, the number of atoms of sulfur 36 in this amount of sulfur 36 is 3.12 times 10 raised to power 6. Okay, that's number of moles, times 6.02 times 10 raised to power 23. It's just making this the subject of formula. If 1 mole of sulfur 36 contains these atoms, okay, 3.125 times 10 raised to power minus 6 moles will contain how many atoms? So when you cross multiply, you get this. Okay, so we have 1.888 times 10 raised to power 18 atoms of sulfur 16. I hope this is understood. Thank you.